Welcome back. This is the second lesson recording for day 8. Where we left off, we just found the polar representation of -8. For -8 in polar plane, radius is equal to 8 because it is 8 units from the origin. Theta for -8 is going to be 180 degrees. So -8 represented in polar form is going to be 8 multiplied by cosine of 180 degrees plus I sine of 180 degrees. Now the next step is to use that polar form to find the cube roots of 8 cis 180 degrees. First thing I am going to look at is the cube roots. If I'm dealing with cube roots, how many answers am I going to get? I am going to get 3 answers. Alright, and now I am going to rewrite this formula here underneath so that I can use that structure. Okay, so first of all, if I have, so the formula says z to the power of 1 over n is going to be r to the power of 1 over n cosine of theta plus 2 pi k divided by n plus I sine of theta plus 2 pi k over n. I am actually going to rewrite that in terms of, break this into 2 separate fractions, and you will see why. So it can be rewritten as 1 over n cosine of theta over n. Okay, so you're dividing by n plus 2 pi k over n plus I and I sine of theta over n plus 2 pi k over n. Just have a slight modified version, and this is going to be helpful for me when I am finding the angles. So, right, let's go back to our problem. What is my original problem is we're finding what is -8 cube root, and we have found the 8 in polar form is going to be 8 cosine of 180 degrees plus I sine of 180 degrees. So what I am doing now is I am taking the cube root of it. So I'm taking third root of it, and that means according to this rule, I need to take a cube root of this number. So I'm taking a cube root of 8, and then this I need to add, this I need to add 2 Welcome back. This is the second recording for day 8. Where we left off, we converted -8 into polar form. So -8 in polar plane will be right here. The imaginary portion is 0, so it only has the real portion. So the radius from the origin is going to be 8. Theta is going to be 180 degrees right there. So -8 in polar form is 8 multiplied by cosine of 180 degrees plus I sine of 180 degrees. Our next step is to find the cube root of 8 cis 180 degrees. This is -8. So first thing you recognize is because we're dealing with cube roots, we're going to get 3 answers. Now I am just going to rewrite down the formula, okay? But I am going to tweak it a little bit by separating this fraction into 2 separate fractions, and you will see why when I am going through some more work. Alright, so I found that -8 is equivalent to 8 cosine of 180 degrees plus I sine of 180 degrees. Then from here, remember I'm trying to get cube root of it, and if I'm taking a cube root of it, that means according to this rule, I need to raise the modulus for the radius to the power of 1 over, in this case, n is 3. So n is 3, so it's going to be 1 over 3, or taking the cube root of 8. And then from here, I need to divide that by n. n in this case is 3 plus 2 pi k. K is an index that we are going to be using in a minute. Divided by n is 3 again. So I'm going to put that in parentheses. And I sine of 180 divided by n, which is actually 3, plus 2 pi k over n. And that's the modified form. So, and then from here, I am going to simplify this. What's cube root of 8? That's just going to be plain 8. Okay, and now we have, oh, I meant 2. This is going to be 2. And then we have these values here, all right? So let's actually, I'm going to separate this and say that I know that this is going to be 8. So cube root of 8 is 2. And now I am going to start using my index. So k is going to take the index 0, 1, all the way to whatever k minus 1. K is 3, or n is 3. So it's going to be k is going to go, so k is going to have the value of 0, k is going to have the value of 1, and k is going to have all the values of 2. You're going to stop right before n, and it was 3, right? So the first case, k is equal to 0. So this is 0, so that means you are left with cosine of 180 divided by 3 is 60 degrees, plus I sine of, again, this is 0 because k is 0, so this is 60 degrees. So this is going to be my first solution. The second solution is when k is equal to 1, so that's going to be 2 times cosine of 60 degrees plus, okay, so instead of 2 pi, I am going to use 360 because we're dealing with degrees. So 360 divided by 3 is 120. So I am going to add 120 to it, plus I sine of 60 plus 120 degrees again. And this, of course, is equivalent to 2 times cosine of 180 degrees plus I sine of 180 degrees. Okay, so we have one solution here, and then we have to find the third solution when k is equal to 2. K is equal to 2, so then this equation right there, cube root of 8 is still 2. It's going to be cosine of 60 degrees plus 360 divided by 3 is 120 times 2, so that's going to be 240 degrees plus I sine of 60 plus 240 degrees, and this simplifies to 2 times cosine of 300 degrees plus I sine of 300 degrees. All right, now we can try to convert this into rectangular form because these are 60 degrees, 180 degrees, 300 degrees. We can figure out what is cosine and sine. What is cosine of 60 degrees? Cosine of 60 degrees is going to be half. I sine of 60 degrees is going to be I times sine of 60 is root 3 over 2 using your unit circle. And this simplifies to 2 times half is just going to be 1 plus 2 and 2, they cancel out, and root 3i. So this is my first solution in rectangular form. Let's look at my second solution. Cosine of 180 degrees is negative 1. So that's going to be 2 times negative 1 plus I sine of 100 degrees. Sine of 100 degrees is 0 times I, so that's just going to be 0I, or you are just left with negative 2 plus 0I. And this is my original real number solution. Okay, it does not have any imaginary portion to it. And then finally, my third solution is 2 times cosine of 300 degrees. Again, go to your unit circle. 300 degrees has the reference angle of 60 degrees. And it's going to be cosine in fourth quadrant is going to be positive. So same as positive cosine of 60 degrees. And that is going to be half plus I sine of 300 degrees is going to be root 3 over 2, except in quadrant 4 sine is negative. So in this case, this simplifies to 2 times half is positive 1, and 2 times divided by 2 is going to be just, they cancel out, and you're just left with negative root 3I. So that's my third solution. Okay, so I actually ended up with 3 different solutions. Now let's summarize this, and we can write the solutions in polar form. This will be in polar form, or this will be a polar form. This will be the polar form of the solution, or this will be the rectangular form of the solution. Now, let's just check what we have just discovered, okay? And let's just pick one of them. Now, what we have just found is this. If I have 1 plus root 3I, if I raise it to the power of 3, I should be getting negative 8. And let's just check, is that so? Okay? So let's just tackle the negative left-hand side. 1 plus root 3I all to the power of 3 is really same as 1 plus root 3I times 1 plus root 3I times 1 plus root 3I, right? And then from here, I can use the distributive property and multiply out each of the term, okay, using FOIL or distributive property, whichever you want to call it, okay? And when I do that, 1 times 1 is going to be equal to 1. 1 times 3i is going to be root 3i, and another root 3i, and then root 3i times root 3i is going to be 3 times I squared, and that needs to be multiplied to 1 plus root 3i. Okay, and let's just keep simplifying this. So this becomes 1 and 3i squared. I squared is negative 1. Negative 1 times 3 is going to be negative 3, plus 1 is going to be negative 2. And root 3i plus root 3i is 2 lots of root 3i. So this simplifies to this, and then we are going to multiply that by 1 plus root 3i. And I am going to again use the distribute property. Negative 2 times 1 is negative 2. Negative 2 times root 3i is going to be negative 2 root 3i. Positive root 3i plus 1 is going to be positive 2 root 3i. And then we are adding 2 root 3 times root 3i. 2 root 3i times root 3i. Root 3 times root 3 just becomes 3. So 2 times 3 is 6. And then I times I is I squared. And I squared is negative 1 times 6. Negative 1 times 6 is negative 6. Plus negative 2 is going to be negative 8. And negative 2 root 3i plus 2 root 3i, they cancel. And the only thing you're left with is just the whole number, just the real number of negative 8. And that's what we discovered, and so it just proves it. Okay, and so we have found the solution. A number, a complex number, when multiplied to itself 3 times, is going to give you negative 8. And you're not going to get there unless you convert it to polar form.